Good morning. Let's go ahead and begin. We're going to work on chapter 3 today, and let's go ahead and look through the PowerPoints, and then we're going to choose an assignment to go and have some fun with. So I'm not going to get too heavy into the PowerPoints here. For this chapter, we have the CN object, and one of the more important portions of the chapter is 3.2, 3.3, and 3.4. Mathematical expressions and type conversions, either implicit or explicit. And the reason being is that when you need to take two numbers and do any kind of process on the operating system, like adding two numbers, dividing two numbers, those numbers have to be the same data type. And before any kind of mathematical expression can be done on those numbers, you either have to have an implicit conversion happen or an explicit conversion happen. And you can just look at the different primitive data types of C++, and pretty much all the programming languages have them. C++, primitive data types. And primitive data types are just essentially numbers, but there's different types of numbers. Different types of ways we work with numbers. Numbers that are just integers. We have characters on the keyboard that are assigned a number through the ASCII character code. We have just true or false values. Then we have the floating point values like 1.2, 3.4. Now the double floating point is just the same as a floating point, because a floating point value is a data type. It's like 3.4, but it's 4 bytes. The double floating point is 8 bytes. Therefore, the double floating point can have a larger value or a greater number of values that it can, represent. And then, of course, there's just the nothing, the valueless or void data type, because something is nothing. And the white character you don't have to really get into too much, but these are pretty much these five are your main primitive data types that you're going to be working with, and they're all just numbers, but they're different sized numbers. And before you can take and add an integer to a float, you've got to graduate that integer to a floating point. If you take a floating point and you divide it by an integer, there could be problems. Or you take an integer and divide it by a floating point, there could be problems because you're mixing an expression, and either the floating point could be implicitly reduced down to an integer, or you can explicitly set it for the conversion and for your processing. So overflow and underflow are not that, and name constants aren't too much. It's at 3.1 through 3.4 are the main ones, and then 3.7 multiple and combined assignment. Formatting output, that's pretty good, but it's not extensively hugely important. However, you're going to want to have some nice output, and if you learn how to do it with just straight up text output and ASCII character codes, you're going to be setting yourself up in the future to be successful when you get into graphical user interfaces and working with streams and files and whatnot. Which characters and string objects? That's a stream. Characters and string objects are what I refer to as a stream of data, either on a file or standard output and input through IO stream, your input output stream. And then, of course, using C strings, it's an old character type string. It's an old school string data type that you guys will not really use a lot, but you need to be aware of them because we have two different types of strings. We have the string object, and then we have, before string object, we used character strings, which is why they're called C strings. And it's just an older form of a string, but it's not object. It's not an object. It's just a sequence of characters in memory that are contiguous in RAM. And we will do an introduction to files, possibly. We'll see how far we can get before we get too much into the weeds and get into having some fun. So when we're working with your CN object, you want to declare, like a variable that you want to use to store it first. And as you can see from this example, we have an integer height. Then we do a cout to the user, prompting for that information. And then of course the CN, what it does is it takes what the user enters and puts it in the variable called height. And that's what the CN put is for, is to grab input from the keyboard for your standard input stream. Oh, well, looks like I hit the wrong button there. Let's see. Okay, we're gonna get back into getting this thing where it should be. Okay. All right. Now, you can use the CN object a little in some different ways. You can use it to input multiple values, but what you're gonna have to do is when you get to this part in your code, you need to put the height, and then you put a space in, and then you put the width, so that it knows the height and then the space width, and then you hit enter, and it'll get both of those at once. I don't like doing things this way. I like to just do one variable at a time with one CN statement, because users don't really necessarily know that this is the way that you can use CN. So I would just do one prompt and then one input, not two inputs like this. I don't recommend doing things that way. To get those actually in, you would type in your height, like 3.4 space, and then your width, 56 or whatever, whatever number. Then you would hit enter, and then those two variables would go into height and width. So again, I don't recommend doing it this way. Just do it one at a time. Okay, so we talked about mathematical expressions and operator precedence and associativity and how kind of things work. So I'm going to get a little bit of a head start because we're going to get into some demo mode a little bit on things that I want to talk about the main parts of this chapter that are important, and then I'm going to leave the rest up to you guys while we go play and do an assignment from the book. So I'm going to go ahead and get started on the assignment from the book by starting up a project, and then we're going to get into demo mode and keep going on one of these. But I think it's a good example to give you another run through on creating a project. We're still kind of learning things. So what I want to do is, for this guy, I want to create a new project, and this is 2019, 2020, or some of the new ones should work pretty close to the same way. And once I get up with a new project, I want to make sure I have C++ Windows console set, and then I want to choose a C++ Windows console empty project. So you can pull down the different languages and output types that you have for your solution or your project. So I'm going to go with just an empty project, and here's the thing: put it on the desktop, guys. Don't hide it from yourself. You really need to have an understanding of your folders and your files. And that's one thing that you're going to start developing as you continue to write software. So I'm going to call this Chapter 3. Chapter 3. Okay. And then I'm going to hit Create. And we should have an empty project that we only need to add the source and main to, which we're going to go ahead and do shortly. So I'm going to go here to Add New Item. You can go up to Project, Add New Item also up here. And we're just going to do a CPP file. Go ahead and call it source. That's fine. That's just going to be our file that we're going to use for programming. I'm going to put in my includes. I want to include input and output. I'm going to do my using namespace std, so I have access to the code written inside of input-output stream that I'm going to use, such as cin and cout. Then I'm going to put my main in and do the traditional return 0. And since I'm on Windows, I'm going to do the system pause here so it doesn't automatically come out of it. So it'll pause and show me my output. Okay, so this is the beginning of a project, and when we have this type of mathematical, or these type of mathematical expressions, this first one, just the number 2, means that's a literal number 2. So that's kind of like doing, let's see, like doing int x equals 2. What that's doing is taking the literal value 2 and it assigns it to the value x. Then we have height. That is a mathematical expression because it's a variable from before when we input height from the user, integer height. Here's us inputting height. And then here is a mathematical expression that represents variables that are being acted upon or processed. And that's where we get into what I want to talk about with conversions and mixed expressions. So mixed expressions are when you do something like this. Float. Let's do 2.2. Let's give it a name. Float y. Int c. Oh, it looks like I got some work to do here on my keyboard. Got my home row off. Int c. And then we're going to say this one is equal to 3. Okay, so mixed expression would be when I would take something like c and assign it equal to y plus x. And why do I call that a mixed expression? That's because we're assigning an integer value, but we're mixing a floating value with an integer value. And this you cannot do. But you can, because what happens is the compiler will see, hey, I'm assigning this to an integer, and I'm adding y to x. Y is a floating point value, x is an integer, so it's going to try to implicitly degraduate this value. Actually, I don't think it's allowed to implicitly degraduate. You have to explicitly degraduate it to make it work. The only way that it would work where it would implicitly make a conversion is if it was graduating. So what if we did a y equals a y plus x? Well, x is an integer, so what it would do, it would know that, hey, I can implicitly convert this x to a floating point. So it would make it 2.0. And now then y plus 2.0 would happen. So the conversions for your mixed data types always happen first. Then your operator precedence and associativity rules take over. And here's the thing if you are trying to take a value such as y and add it to x, you could get an error or warning here about conversions. And it looks, why are you doing this? This is so stupid. Okay. All right. Okay. So in any case, sometimes it can handle it. Sometimes it says it cannot handle it. I can't do the conversion before I take this floating point value and add it to an integer. And therefore, you have to make the conversion happen yourself. And since we are assigning it to an integer value, it makes the most sense to take that float and say, hey, convert that y to an integer first. And that's what this is. This is called typecasting. And notice how I'm putting it in front of the variable. And what I'm doing is I'm saying convert y to an integer first, and it becomes 2 and truncates the point 2. Then it adds to the x. and then assigns it to the value x, which is, totally fine. But that's the idea of conversions, implicit and explicit conversions, because when you put a data type on the CPU for processing, it has to be the same type and size, because it's the actual physical thing happening when they process those ones and zeros off of your transistor, off of those transistors. So that is a true thing for all programming languages. C++ does not do the best job of handling it. Other languages such as JavaScript and Python do. They just do the conversion for you, essentially. So you don't have really much control over it. Well, you do, but it's a little bit more automatic than usual. Okay, so that's implicit and explicit type conversions and the reason why they're important. And then we get into your mathematical expressions and operator precedence and associativity. And what will end up happening is you may have a long cascading C plus X times 2 divided by Y multiplied by 1. Whatever. Okay, so that's a fully good expression, but the thing is that only one process can happen at a time. Meaning that you can only add C plus X. It can't add them all up. Essentially, it's just the way you did. You learned it in elementary school. You got to break this down and decide, well, which happens first, and that's where operator precedence and associativity comes in. And you can actually look up at the charts for operator precedence and associativity. It's the same for any language, so it doesn't really matter what language type you put in up here. You can put C++, operator precedence, and associativity. That's basically how your operators work. Do they work from left to right for the operand, or right to left for your operands? An operand is the number that you're working on. So this is the operator times X is the operand, 2 is the operand, Y is the operand, times is the operator. And that's some of the vocab. Okay. And when you look at the operator precedence and associativity, you'll see a chart kind of like this, and you'll see here that multiplication has a higher precedence than addition and subtraction. So we know that multiplication is going to happen. But what if that multiplication, there's multiple multiplication, and we see here that we have 2, and then we decide, well, what happens first? And that's where we go to your left to right. So that means that all operators, no matter what associativity, if they have the same precedence, they must be evaluated from left to right. Since times, divide, and divide have the highest precedence here, the first thing we're going to do is work on the one that's leftmost. We don't do the x yet. We do the x times 2. So x times 2 is 4. Then we divide it by y, and we take y 4 divided by y is 2.2. Now, since we're taking an integer, it could just truncate and take 4 divided by 2 and give you 2 here, because we're taking an integer and working with a float, so it may convert it to it may give it. No, it's going to truncate it and just be 2 because you're mixing your expressions. And so that's going to be 4 divided by 2, and then it'll do the 2 times 1, which will be 2. And I could be wrong with how it's evaluating it, but that left to right behavior and the operator precedence and associativity is kind of the way it works. And of course, you already know this. You learned this in grade school. However, when you get into the other operators that you probably don't know about, it's important to have that kind of understanding when you're working with some of these other operators and know what actually happens first, second, third, and whatnot. Okay, order of operations. We just talked about that. Cool. Evaluated second, first, evaluated third. Okay. Associativity of operators. Okay, so this is about either left to right or right to left. And usually you only have mostly it's all left to right associativity. That's how you learned in grade school. When you take an operator that's evaluated from right to left, that means that it takes and it operates on the operand that is to the right. So a left to right operation is operating on operand that's on the left. A right to left is operating on the operand that's on the right. So let me give you an example of unary operation, or a unary right to left associated operation. And that is going to be something like x is equal to -2. So what happens is the sign is applied to 2 first. The negative is applied to the 2. And then that value is then assigned to x. And that's where the operator is applied to the operand from right to left. From left to right, you take the plus, and it's operated on the C with the 2 being passed into it. Meaning it's operating the plus on the C by adding 2. And that's the left to right associativity. Now it gets more complicated when you start really mixing things up, but the main thing that you're going to be working with is the operator precedence and associativity of plus, minus, divide, subtraction, a lot of those first before you get introduced to some of the other operators out there. All right. Algebraic expressions. These ones you're going to have to port and work and make work. So like to find the power of a number, we can use the math library, or we can just take s times s. We can just take s times s, and that would be s squared. And so you can do it without using the math library. You can do s squared very simple. You can do it just like you can do c squared here, c times c. It does not work where you can have where it's intelligent enough to handle for those particular ways in mathematics that we learned, like to take a power of 2. Now you can actually run a math function that'll do the power routine for you from the math library, or of course you can just do it like I showed you here. There's a power of c squared. But that's kind of the idea, is that when you actually do it with code, it's going to be different looking than what you see in mathematics, which just makes simple. It's because you're writing code with 128 characters on the keyboard, and you're pretty much, that's what you have to use. So we use the backslash to implement or denote division. Parentheses we surround by things that we want to happen first, forced to happen first. For example, is if we had c times c plus c. If we wanted to force that plus to happen first, before the multiplication, I would surround it with parentheses, just like you learned in grade school. All right. That kind of gets us through to some of the more important aspects of this chapter. I've already talked about implicit type conversion and explicit type conversion. We talked about hierarchy of data types already. Type coercion, that means conversion of operand to another data type. We talked about why this is a problem with promotion and demotion, because data types have to be the same when you process them. If you demote them, if you take a floating point and make it to an integer, you're losing data. And that's when an implicit conversion won't happen with the compiler. You'll have to explicitly do it with the typecast, as I previously showed you. Okay, here is an example of an explicit type conversion. This is the old way of doing it. So you notice here that they just do static cast char. I do it this is the new way of doing it. I do it the old way, which, you know, the new way is C++ centric, but when you look at the new way and you look at the code wrote to make the new way, you're just going to see the old way inside. Yeah, seriously. Yeah. So I'm going to show you, this is an example of the new way. I'm going to show you the old way. So if I want to take the number 65 and convert it to a char character and then output that, I could do something like this. I could say, hey, integer x, s equals, let's say 65. Okay, now let's take that and let's create a char called C and assign it to s. Now we're going to get a problem here because it's going to say, hey, I don't know how to do this conversion. You're trying to take an integer here and convert it to a char character. Well, we know that chars are all numbered in the ASCII code chart, and 65 happens to be the letter S. So what I can say is, hey, take that numerical value S and convert it to a char. And that is the explicit type conversion. The old school method, which I would suggest using because the new school method just has that inside of it. That's pretty, that's usually the way it is. But in any case, what this then does is take that value 65, converts it to a char, and since it has the integral value 65 assigned to it, it's been assigned the value A from the ASCII code chart. And you can look into the ASCII code chart. Go ahead and look it up. It's spelled ASCII, ASCII code chart. ASCII code chart. Look into that. That's pretty much your main basis of everything that you're working for, your input and your output, and what you use to write code. It's everything is in the ASCII code chart. Okay, so this would output the value A if we output C. For that explicit type conversion. Well, if we didn't have any errors, it would. And that's probably because I'm doing something I shouldn't be doing, but let's clean things up and try to get things working, and so that I can at least show you when we get to working on our assignment for this video today. Okay, that works. Okay, so let's look at our output. And we should have our letter A there, and there's our letter A. From converting the integral value 65 to its corresponding char data type, and since it holds the value 65, it's already assigned the numerical value A, which is what is output. Okay, and I don't want to get too far. More typecasting, you guys get into that. Older typecasting, that's what I just talked about. Overflow, underflow, I'm going to let you guys cover that. Named constants, you guys can cover that. Multiple combined statements, you guys can look into that too. That's pretty much here we go. Combined assignment statement. Let's look into this one a little bit, because this is, I kind of say that a lazy programmer is a good programmer, because the less code that you write, the better your program is, because that's the less chance there is for complications. So this is, if you ever want to do something like this, where you are taking an integer value and you assign it to itself plus 3. Something like that. Well, that's done so much because we call these accumulators. Basically, it takes a previous value of S and takes it and adds 3. Well, this is going to fail epically because there is no previous value of S. So we actually have to do 0 there and make sure that there is a previous value of S. Then we can say S is equal to S plus 3. So what that's saying is the new value of S is equal to 0 plus 3. And then it's going to assign 3 to the new value of S after this line is done, completed. So when you're working with these shortcuts, it just makes that, because it's such a common thing that happens, we shortcut this. We make this a shortcut, and we say s plus equals 3. And s plus equals 3 is the same as saying s is equal to s plus 3. It's just a shortcut. That's all it is. It's just a shortcut that programmers like because we're lazy. Well, no. I mean, a good programmer is a lazy programmer, but no, programmers are not lazy. Hundreds of lines of hard working code, thousands, millions of lines of hard work go into a lot of software out there. And nothing is done by magic. It's all hard work. Okay, so that's your shortcut. Here's some more examples of the shortcut. I'm going to let you guys get into the formatting output. I think we've gotten string input. You guys can get into a little bit. String operators. Here is using C strings. This is the old school type of string, and I want to kind of give you a little bit of a difference with it. Is you're not going to be actually using these right off the bat. These you won't see too much until you hit 162. And they're the old school style string, and where you have the ease of use with a string, that you can use special operators with a string, such as like a plus to concatenate them. You cannot do that with a C string. It doesn't have a plus, the capability of doing a plus. With a C string, you have to add or concatenate two strings, you have to send it to a special function called string copy. And it's the old way of doing things. It's all function based. It's not based on objects. So you guys won't be using them much. And since the string object itself is, object oriented, one of the main differences that you have is a string object called words here has a property called length. So the string knows how large it is. With a C string, it doesn't know how large it is. It's not an object. It does not have a length property inside of it. So they terminate it when you're done using the possible size of your string. They terminate it with a \0. Now you guys haven't even talked about arrays yet. So strings are essentially arrays. And so we can't really get too deep into this. The only thing I can give you, is just remember that strings and C strings are the same, but fundamentally different in how you use them. C strings are old school function-based code, and strings are object-oriented code that's easier to work with and has more operators that you can use with them instead of relying on function-based libraries to work with those strings. So let's look at the string data type, and I'll give you kind of an understanding of what I mean. So string strt equals hello world. Okay, now here's one thing that the string has access to, is it can tell how large it is. So you see I did a dot there? Because it's an object, it has access to other things inside of it. It has access to different things inside of it that you can work with. And one of those is count or length. So we know how large the string is in case we need to loop through each character and look at each character. Or we need to format that string in some way. And that's important. But a C string, let's say that you do a C string where you do a char array and you say it's going to be 100 characters, and you can't use the equals hello world here. That one won't work unless they fixed it, but I don't think they fixed it. They may have. Oh yeah, they did. They fixed it. They made that work. But if you did that anywhere else after the declaration, you'd have to use the string copy. But they put a \0 in here, and it's in there and you can't see it. But what it does is it tells see out when it prints the string to stop printing, because you create the string and you say, hey, it's a string that's capable of holding 100 characters. It's limited to just 100 characters, but if you try to see out that, it's going to output all 100 characters. So you give it, you tell it, hey, you can hold 100 characters, but then you assign it a value and put \0 in there, so see out knows when to quit outputting information. Now, since a string is smart enough to know how large it is already, the cout method knows that a string has a count or a length, and to stop after printing the characters in the string after a certain length is met. And that's kind of the difference between C strings and strings. Strings are fully object-oriented with self-awareness. That means objects have data inside of them, and also properties and behaviors that are meant to be used on that data inside the string. It's kind of like a self-contained entity, very, where a C string is not. It's just an array of memory. You have access to it, but you don't know. You would have to have some special things, because there's no way we can go in here and just say SAR dot length. It's not possible. It's a primitive variable. It's not an object. So that's not going to work. You can't do that. So we have to know the length of the string from the \0 no terminator that's embedded inside the string itself, because it has no self-awareness like an object-oriented string. Okay, and again, that's a long talk for something that you're not really going to use much for a while, but it'll give you a little bit of an intro to it. Okay, so this is C string input. Again, you're not going to see it a lot, but you notice here where they're using a getLine function. That is so that you can read in a C string, because CN uses spaces as a null terminator, or as a terminator. So if you try to enter in a sentence, it's not going to work, because if you type something in, hit space, that is going to go into your first CN. So like from our previous example, if I did a CN D and then a CN A, and I said type in a sentence, and I said, hello world, this is a sentence. Well, okay, the H would go into the D, because the space terminates that particular CN, and then the world would go to the A, and then this would just all get lost. So to get a sentence with spaces in it, you have to use that getLine function, and because CN is not smart enough to know that whether you mean a sentence or just a word, because it uses spaces as a delimiter, not the return key, spaces, and the return key actually. Okay, I really want to get to writing some code right now. I think we're getting close to maybe some of the more mathematical functions. You guys can look into that. I think introduction to files, file input and output. Files are kind of done just the same way as your input and output to the screen using IOStream. So, and it's a stream where you take, and the files that you write are text-based, meaning that you have to go to another conversion of converting numbers that are in memory to ASCII code to output to the file as ASCII characters. And we use input file stream to input a file, and output file stream to output a file. And when you open up a file for text input, or for binary input, you use this, what I call the file pointer. This is the file pointer. It's a instantiation of the type input file stream library called infile, and we use this infile variable to actually work with our file. And I call it the file pointer because when you open a file, the file pointer always starts at the beginning of the file unless you tell it not to. And then whenever you do a read or write, that file pointer moves along in the file, kind of like when you're reading a book, your eyes move along in the book, or when you're writing, your pen is moving along. So as you're progressing into the file, that file pointer is moving with your read and write statements. And then you use that file pointer to access the file by opening it. And often, if you're doing it for reading, the file must exist. If you're doing it for writing, it will create the file for you if it doesn't exist. And then you get into using of the file. Every time you do an output, you're using out file like you're doing cout. But what you're actually doing is, instead of outputting like cout outputs to the screen, out file takes that output, instead of going to the string, directs it to a file. So it's just kind of like that cout and that cin, that IO stream, input output stream that goes to the screen or a file, is the same. Except for they're just directed to the file. And the same thing works for input. This is just like cin, but what it's doing is it's reading it from the file. And then here's the main thing that you want to do when you're doing input and output, text input and output from the file. You need to close it. Because if you don't close it, then it'll get you won't be able to use it. It's just toasted. You'll have to delete the file. The idea here is that maybe other systems may need to use that file. So the goal is when you're working with files, you get in, you get your information, you close it, and you get out. Or you get in, you output your information, you close it, and you get out. You don't mess around with opening a file and doing other stuff in your process, because you want to do it as quickly as possible. We have not solved the problem of multiple users accessing the same file and being able to edit it at the same time. I don't think it's solvable. Yeah, possession is 9/10 of the law. All right, let's get into an assignment. Let's go ahead and get into your vital source here for an assignment. Let's go ahead and chapter 3. And I may only have time to just get you started on this, but let's go ahead and delve into. And I'm gonna take a break real quick and come back to this. So I'm gonna stop the video and I'm gonna resume it here. But let's go ahead and choose the assignment that we're going to work on when we come back for our break. I want to go ahead and, maybe it's time you guys have a little break. I'm usually after an hour of talking. I'm hoping that we can keep this to an hour, but if it goes to an hour and a half, that's fine, because we're having fun doing stuff, at least, instead of just falling asleep with Mr. B doing PowerPoint. Okay, so let's go into a choice for what we're going to go on 3, and a lot of what we're doing is just calculation based. Now this is my favorite one, because this is where students always have a problem with mixed expressions, and that's the Celsius to Fahrenheit conversion. So what we're going to do is we're going to ask the user to enter in the Celsius, and then what we'll do is we'll process and output the Fahrenheit. So what I want to do is I want to first hey, what am I doing? This is what you want to do. Oh, well, my input is Celsius. My process. Well, what is my process? Well, it's going to be, what is Celsius equal? Celsius is equal to, let's look at the, here we are, where's the formula? Celsius is equal to 9/5, or 9 divided by 5, and let's do a little porting from the mathematics, times, we input Celsius, and we want Fahrenheit. F equals 9/5 times C plus 32. Now let's see if I can't cause the problem to happen because what we're doing here is we've got mixed data types. Even though we have all integral numbers here, when this 9 divided by 5 happens, that's going to create a problem, because 9 divided by 5 is going to be a number less than 1, which may get truncated and be 0, and then you will just have 0 times C plus 32. So there's a lot of conversion problems that can happen. And you want to be explicit with your conversions. And whenever I have division, I just go ahead and say screw it and make them all floating points. But that's not necessarily every time. You know, that's the way I would handle this problem. That would be the best way to do it. But a lot of you students will make this mistake. Well, you'll go with float f. Process. What's my output? My output is Fahrenheit. Okay, so you notice here that I've got my input Celsius process. I've declared what my process is. Now I'm going to have my output, which is F. Okay, you guys want to do an IPO chart. It really helps you get what you need done and kind of, it's your way to get started. Okay, so I'm going to do a CN of F. I'm going to tell the user, hey, enter Celsius. And then what I want to do is I'm going to have another floating point called C. And I'm going to do a CN of C. Now here's good programming habits. I guess I'm not going to pause because this one's quicker than I thought. So we're not going to take a break. We're just going to get it done. 0.0. Okay, you guys can pause and take a break, of course. This is good programming habits right there. You notice I declare the variable and then I assign it a literal variable of its data type. I do not assign it to 0 because that's not a floating point number. This is a floating point number. Okay, now I'm going to have the user enter Celsius, so I'm going to do a CN of C. Now here's one thing that I always tell students to do. Get your memory, print your memory. Okay, once you get it from the user, print it. And then and don't get too many lines of code written without testing stuff. So right here, I'm going to just do a CN of C, and I just want to see that I'm actually getting the variable and I can start working with it. That's simple. And what I'm going to do is I'm going to go ahead and rebuild. I'm going to stop debugging. Okay, and I'm going to run this. And I'm going to enter my Celsius. And there's my 56 powered back at me. Okay, now I'm ready for process. Well, what's my process? Well, I don't want to see out C. That's going to be F. My process is actually assigning F to something. So I'm going to do this the improper way, the way most students make a mistake, and they'll do it like this. This may or may not work because here's the problem. We're taking a floating point number and mixing it with these integral types. And that floating point number and the truncation that can happen, if we are stuck taking 9 divided by 5 as an integer, it's not going to even get the floating point part of that value. And I want to show you something else after we run this. I want to show you the debugger. So let's go ahead and run this once and just look at the output for what we have. And then I want to show you the debugger and kind of what's happening behind the scenes. Okay, I'm going to enter Celsius of 45. And we get 77. Is that even close? Celsius to Fahrenheit. 45 to F. Oh, okay. 45 Fahrenheit, it should be 7.2 Celsius. So what did I have? I had, that's my other output. 77. That's not right. And the reason being is because I'm mixing expressions. If I wanted this to behave appropriately, number one, I wouldn't be mixing expressions. But I could do this. I could say, hey, make this a float, and then this a float, and then this afloat, and then do the addition, division, then do the processing. Because before processing can happen, they have to be the same size. And now we're not going to have any information loss because it knows that it's taking a floating point 9, dividing it by a floating point 5, getting the value that's going to be a temporary floating point, and then adding and multiplying that by C, which is also a floating point. So we're not going to have any problems here because we are typecasting. And typecasting actually has higher precedence than multiplication and plus. It actually happens first. Okay, so now let's go ahead and stop this and let's run it now and look at the difference that we get. Let's do 45 again, and we still got problems. 45 Celsius to what? Wow, this is getting too ridiculous. It's hard. Let's check this out. How close am I? 45 Celsius to Fahrenheit. I'm getting 113. 45. Oh, I'm doing it backwards. I bet you guys already. Yeah, I was doing it backwards. Oh, we got it right. Okay, so it was wrong previously before with that 7.2 because I was just looking it up wrong. so yeah, it came out to 113 the way it was. And remember, if we go back to where we're actually not doing it correctly, we're getting 7.2, which is, or 77, which is totally incorrect. So data types matter and conversions matter. So you can do the explicit type conversion, or you could just say, stupid you, 0.0. Okay, so when you're being literal with data types, be literal. Put the point in if you're using floating points. It matters. In fact, it's probably the most important thing from this chapter to kind of understand in typecasting, which is one reason why C++ is a popular language, is because it's low level and extremely fast. And for such a low level and fast language, the typecasting it is capable of handling is supreme. Because every data type has to be the same before you process it on the CPU. It's a physical limiter, Okay, this is an example of the Fahrenheit to Celsius. Make sure you choose a different one for your assignment, please, and know about that typecasting and whatnot. And I'm going to go ahead and call it a day. Thank you.